Hello and welcome back to Oz's Television Workshop. This video we're going to be assembling the VIC-20 Hyperexpander. It's an open hardware project. Details I'll put down below. This video was originally as part of the VIC-20 repair video, but let's face it, that thing ended up being almost feature length, so I've chopped this out and made it its own separate entity. So please enjoy. Cheers. Okay, so we've assembled some parts. I've put the PCB in my assembly frame. What have we got? We've got some memory ICs. We've got some EEPROMs, unprogrammed. In fact, that one isn't even erased as yet. An EEPROM socket. A couple of 74LS148 octal encoders. A little bit of header there. Two of these wonderful piano key type DIL switches, 100 mic capacitor, 3 1N4 and 48 diodes, and a 10k resistor. And all we've got to do is fit that. I've got a nice socket for the EEPROM as well. So yeah, off we go. I will need the workshop blue tack to hold the parts in as we solder them. Yeah, this board, by the way, it's very configurable. I'll leave the link to the chap's website that designed it below, but you don't have to populate it all. Now I'm going to do it because I want it to be quite versatile, but you can configure it in different ways to do different tasks. It's very versatile. Clever bloke that sort of reverse engineered it. There's a few instructions on the back there. There we go. Right, let's get it together. So we're going to need a warm soldering iron as well. And some solder, of course. Right. I am going to start by actually fitting the diodes first, I think. So we shall form those up. Board is very nicely designed. It's available sort of singularly on eBay if you want, or if you want to send it off to get it made to JLC PCB or PCBWay or Dirty Prototypes or any of those board manufacturers, do so. The Gerbers are available. The guys also produced a set of EEPROM images, which is very good. So we will have a go at blowing an EEPROM in a bit. Right, that's the 3 diodes fitted. Let's just stop them falling out and solder them up. This board, by the way, I bought a single one from eBay, so I don't end up with 4 that I don't want. Although, to be honest, I think I've been a bit hasty, because look at the different configurations. There's one configuration where you can have 2 EEPROMs on board, which I think would be very useful, and not as much RAM. Still, we haven't got that, so if I want another one, I shall just go and buy another one. Okay, right. There's a 10k resistor. Take that off. There's a 10k resistor to fit at the bottom here. I fitted these 2 resistor arrays earlier. They were intended to be filmed, but due to a slight mistake in not pressing record on the camera, we didn't get that. It's all through hole construction, which those of you that know me know I'm not a great favour of anymore. I always used to think surface mount was difficult, but it really isn't once you get the hang of it. There's none of that tedious cutting off of the legs that take so long? I don't know. Your mileage may vary. Right, that's that and that and that and there. In fact, I'm going to put those capacitors in place next. Right, these are just ordinary 100 nano capacitors. Anything over 5 volts is good enough. These ones are 50 volts. That's what we've got. So I stick those in. These just decouple the supply to each IC. Proper design, see? And you see why I hate through a hole. There we go. 1, 2, 3, 4, 5. There we go. Okay. Missed one. The glare coming off this board, because it's so shiny, is quite something else. Better. Okay. Brilliant. Let's put the EEPROM socket in place. Okay. Right. Put that 100 microfarad capacitor in place. Design calls for a 16 volt capacitor. I haven't got any, so we'll put a 50 in there. It'll last forever. It's got the same pin spacing anyway. There. Quick close-up check. It's all good. Right, let's put the two encoders in for the high and low RAM. So I need my chip shaping tool. See if that's any better. Perfect fit. Epic. Right, a reset switch. Be advantageous if we fitted that next. That's just designed to hold into the board perfectly on its own. That's good. Super. Right, the little piano key dip switches. of these, I think, got a slightly bent pin. Yeah, let me just... is it going to straighten out in here? Yeah, I think so. Much better. These dip switches will allow us to have multiple bits of EEPROM that we can switch in. So we can have many functions in our one EEPROM. You know, a few diagnostic utilities, perhaps dead test and the full VIC diagnostic test, video test, and a few other things. Or maybe, you know, a multi-games ROM, perhaps. Especially as the ROM chips are somewhat larger than the originals. Okay. If you look at this board as well, you can fit a number of different types of dip switches. The holes in the board will accommodate several different packages. I just like the look of these piano key ones, and they're not expensive. Looking very good indeed. Okay, we should take that out. We should put the pin header in. There's a little jumper here to select the size of the EEPROM configuration. You can have 4 or 8K. No matter what I do for a pin header, it will never be straight. So we can do this one a little better. They never seem to sit in straight for me. Always at a jaunty angle. Okay. Cool. Do you know, that's not bad at all. First time for everything. Right, now, memory. If you did watch the ZX81 video that I did in part 1, amending the micros, you'll know we upgraded the memory using a 62256 memory IC, and that's exactly what we need here. So you can have 2 EEPROMs, or you can have 2 loads of RAM and an EEPROM. So I'm going for 2 loads of RAM and an EEPROM. So yeah, so we're going to have 2 lots of 32K RAM. Again, same with the ZX81, of course. We could only address sort of 16K of that memory because of limitations of the machine. And in this case, despite the fact we will have 64 by 8 memory, 64 by 8, we will only be able to address 37K. Even so, these things aren't expensive. The Certainly today they're not, maybe tomorrow, who knows. But yeah, these are CY 62256Ls, and they're just the job. So better if they'd fit in the hole. Come on. I think I might be caught on the edge of the jaws here. Let's just push that down a bit. Yeah, that's the problem. There we go. Right. So the hardware's coming together very quickly indeed. Good news. So we've got low RAM and high RAM. There's bound to be an Etsy seller or an eBay seller selling these things complete with the EEPROM of your choice. Bound to be. Perhaps I'd make a living if I just sat here all day soldering these things up. Who knows? Okay. There it is. The hardware for the Hyperexpander is complete. Fabulous. Quite a neat job. Right, next thing we need to do, of course, is blow the firmware onto our PROM. Let's get on with that. I have plugged in the TL8662 EEPROM programmer into my machine. I've selected in the software the right chip. I hope it's 28 pins, so let's drop it in. Now, memory serves, these are blank. So, yeah, I'm hoping we can test this for blank. Verify blank. Blank check. Yes. So, let's get our device info. Fairchild, blah, blah, blah. Yep, we're in 8K. That's good. So, I just need to verify blank. So, let's just check that. Device ID is correct. So I'm just going to do a blank check. Click the blank button. Device is blank. Fabulous. Okay, so hidden in my downloads folder, I've got Hyperexpander firmware set 1. I'm just going to extract that. Lovely. And yep, we've got a PDF file in there. I shall open that later. I shall now load Hyperexpander firmware set 1, downloads, firmware set 1 bin, open. There we go, we want it in binary, default file load, okay. And then we go to the flash tab. There we go. So we can see there's text and data in there. Right. This worries me. IC configuration, VPP 13 volts. Well, I've got a programming voltage of 12.5. So, yeah, well, maybe they can only do 0.1s. Right, okay, let's do it. We've got plenty of these anyway. So, pin detect, skip. We don't want to skip blank. We want to do blank check. Oh, you skip the blank, yeah, because it's an E squared Brom. I think we're good to go. So, let's hit the programming button. Yep, and we are plugged in. Yep, program. There we are. Verifying programming succeeded. Brilliant. Okay. So I'm just going to go back into that. I'll tell you what else I'm going to do. I might as well load the Hyperexpander set 2 as well. Why not? Extract. Boom, 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 boom. So I'm just going to get another EEPROM. Let's remove that one. Cheap ZIF socket, or have I got a bent pin? Ah, got a bent pin. Ease it out. There we go. Good. Okay. So let's load set 2. Expander set 2. Set 2.bin. Okay. That's change. Set 2 bin. Yep. Okay. So let's just do a blank check. Bad pins found. Oh dear. All right. Okay. Pin detection error. Always worth doing things like this, because otherwise you could... bad pins found still. Never good. Which ones it say? Ooh, those two there. They look okay. Blank check. Pins detected passed. IC okay. Excellent. Right, okay. So there's our set 2 data. Let's program it. Verifying programming succeeded. Brilliant. Okay, let's move back to the VIC-20 and see if we can get the dead test to run. So there you have it, the VIC-20 Hyperexpander. A great little project and well worth building one up if you're into your VIC-20 stuff. There we go. Thanks for watching. Click like, subscribe, ring the bell, all that rubbish. And I'll see you really soon here on Doz's Television Workshop.